All right, this is my second take on this recording because the first time I did this, I forgot to record my audio. So here I am doing it again. All right, this was the question we talked about in class that I was really kind of struggling through. I didn't actually think about the setup of this completely properly. So I'm going to give you a way to do this in all instances. This is a work problem is what we call this. I'm going to read it out loud and then we're going to tackle this. Maxine can paint a small room 12 hours faster than her friend Trinidad and 4 hours slower than the two of them working together to paint the same room. So how long would it take for them to work together to paint that room is really the question. So we're going to build a table. That's actually the not trick. I don't want to say trick, but that's the tactic here. So I'm going to go ahead and quickly throw together a table. I'll make 3 columns. So the first column, let's do this. And the second column, I'll just place right here. And the third column, I might as well just do right here. And we'll have a header for that. So let's go ahead and put that in here. And that header is going to have, let's say, the name of the person. This second column will have for the time, and I'm going to make a little note here. This is the time to paint a single room, or in other words, the time to complete a single job. So I'll just say to complete one job. The job might be painting a room like it is in this case, or it could be building or making food or something like that, making pizzas or whatever. All right. The third column will be the rate. And this is in jobs per whatever unit of time it is. In this case, it's per hour, but you can think of this if it was, let's say, I could restore one car in 12 months, right? So it's number of cars per month or something like that. But this is jobs per hour in this case. And that last column we actually didn't need. All right. So let's see the names of people involved. Well, we have Maxine. I'll write that in. And we also have Trinidad. And then we have them working together as well. So I'm going to use a different ink for that. And in fact, I'll go ahead and close off this grid here. And I'll use blue ink for them both working together. Now let's read the problem very carefully. Maxine can paint a small room 12 hours faster than Trinidad. So the time she takes to complete a job is in terms of the time it takes Trinidad to complete a job. So I'm going to go ahead and let T be the length of time it takes for Trinidad to complete a job. Now you don't have to do it this way. You could actually tackle this a completely different way. You could go about and say, you know what? I'm really, because everything's kind of centered around Maxine, I'd like to just figure out everything in terms of Maxine's speed to complete a job. And so that's the way I'm going to do it here. You don't have to. You could do it in terms of let T be the time it takes for Trinidad to do the job. And then based upon that, you know that Maxine, the time she takes, is just 12 hours faster, right? Well, all right. So I'm switching the role here. I'm letting T be the time it takes for Maxine to complete a job, which means that Trinidad, because she works faster than Trinidad's going to take more time. It's going to take the time it takes Maxine plus 12, right? Because again, Maxine can paint that room 12 hours faster than Trinidad. So if she took 1 hour, it takes Trinidad 13, that type of thing. Now, the key here is to note, if they're both working together, and again, let's just pretend that Maxine takes 1 hour to paint that room, so Trinidad takes 13. If they're working together, you're not going to add those two. It doesn't take them longer to paint a single room, right? Because Maxine can do it in 1 hour. So it shouldn't take 1 plus 13 or 14 hours to do that. That makes no sense. So we're not going to add those two to determine how much time it takes them to both do the job. So I'm just saying that because I need to. The rate at which they work, well, it's pretty easy. It's just a reciprocal of the time. Remember, this is all based upon the formula work equals rate times time. And so rate is the number of jobs done divided by the length of time it takes to work on those jobs. Well, if we're assuming that we're just painting one room, then, for example, Maxine paints one room every T hours because T is the number of hours it takes her to paint a room. So she paints one every T hours. Trinidad, he paints the same one room every T plus 12 hours because he takes longer. That's just Trinidad. That guy's a bit lazy, right? All right. Now, the rate when they're working together, you do add. So Maxine is working at a specific speed, so is Trinidad. When they work together, you actually do add their rates. Here's a way you can think of it. If you have a bike, so here's my terrible looking bike. This is just a terrible bike. Anyway, if you have a bike and let's say you're moving forward at, I don't care, 6 miles per hour, right? And then all of a sudden there's a push from a strong breeze or a strong wind from behind you, and it's pushing you an additional 2 miles per hour. Well, then your total rate should be 8 miles per hour. You're going to add those two rates, right? The stronger the push from behind, the faster you're going to go. So it should make sense that you do add the rates. So when they're working together, their rate working together will be Maxine's rate plus Trinidad's rate. There we go. Now let's take a look at that unfilled box. That's actually the hardest box to fill. Although, to be honest with you, I think Trinidad's time was very challenging as well. So let's see. Maxine can paint a room 12 hours faster than Trinidad. Well, that's exactly said right here. She takes T hours, he takes T plus 12. He takes 12 hours longer. Okay, that's fixed. But what about that second piece? And 4 hours slower than the two working together. So when they work together, it takes a certain amount of time, and it should be actually faster than Maxine's time, right? Because not only is Maxine working on this room, but Maxine and Trinidad. So it should be faster than T. It should be something faster than T. So I'm going to write here T, the length of time that Maxine would take, but a little bit less, right? It shouldn't take all of the time that Maxine takes. It should take time plus or minus, actually minus something. Well, we know she's going to work 4 hours slower than them working together. So I'm going to put minus 4 here because logically it should make sense. If they're working together, then whatever time it takes should be less than them working separately. So for an example, let's just pretend that working by herself to paint a room, it takes Maxine 20 hours. Therefore, working by himself to paint the room, it should take Trinidad 32 hours. And if they work together, it shouldn't take 32 hours, nor should it take 20. It should take less than both of those, specifically 4 hours less than Maxine's time. So that'd be 16 hours if they work together. Now, that's fictitious. I'm not saying that's actually true. I'm just saying logically, that should make sense to you. All right. So you take, because it takes Maxine, she's 4 hours slower, so it takes her 4 hours longer to paint that room than if they were working together. The both time is T minus 4. At this point, I get to focus in on that bottom row because we want to know how long does it take them to work on this together. Well, remember, this is all built on the formula W is equal to RT. W being the number of rooms that get painted, R being the rate at which they paint, and T being the amount of time it takes them to paint that room. Well, if that's the case, W is 1. They're just painting one room. They want the work done to be one room worth of work. The rate at which they work is 1 over T plus 1 over T plus 12. That's the rate at which they work together. And then the time it takes them to paint a room together is t minus 4. This is all from that bottom row. Here's my equation. I'm going to multiply both sides by the LCD. The LCD is t times t plus 12. So I'm going to multiply both sides by t times t plus 12. So I get t times t plus 12 on the left-hand side is equal to, well, when I multiply this whole side by t times t plus 12, I'll take the t and the t plus 12, and I'll distribute it just into this fraction right here. So I'll get t plus 12 plus t times t minus 4. Cleaning up the left-hand side, I get t squared plus 12t. The right-hand side is 2t plus 12 times t minus 4. Cleaning up that right-hand side, t squared plus 12t is equal to 2t squared, let's see, minus 8t plus 12t, so that's plus 4t. Let me just make sure, minus 8t plus 12, yep, that's plus 4t, and then minus 48. Moving everything over to the right-hand side, we'll get t squared minus 8t minus 48. Factoring that right-hand side, because it actually does factor, that's t, see, two numbers that multiply to 48, that's 12 and 4. So minus 12 plus 4. Let me just double check my mathematics. Yep. So our solutions are possibly t equals 12 and t equals negative 4. Now remember, t is the length of time that it takes Maxine to paint a room. So obviously t equals negative 4, not realistic. So it takes Maxine 12 hours by herself to paint the room. Well, if that's the case, if it takes her 12 hours, then it takes Trinidad 24 hours by himself to paint the room. Working together, remember t is 12, working together, 12 minus 4 is 8. It takes them 8 hours working together to paint the room. So that is actually the solution. 8 hours working together to paint the room. And I apologize that I just did not do that in class. It's just because I had, like I said in class, that these have always been a very hard style of problem for me. I don't know what it is about my brain and these types of problems. I can do advanced mathematics, but these always just cause a hiccup. But if you create a little table like this, where you have a column dedicated to the time to complete a job and a column dedicated to the rate at which they're working, and the rows being the names, and then a final row being them both working together, you will be fine. All right. Again, sorry about the hiccup, but here you go. All right. Have a wonderful day.